Hi everyone, this video is in continuation of my previous video, and here we are going to do a chi-square test to check whether our observed genotype frequency is in Hardy-Weinberg proportion or not. So before that, we have to convert these expected genotype frequencies that we have got into a predicted number of individual. So to convert this, we have to do is multiply these expected genotype frequencies with the total number of the individual. For each genotypes, let's do that first. Here 0.29103 into 6129. Then for Mn genotype, it will be 0.49687 into 6129, and then for NN genotype it is 0.21206 into 6129. So for MM genotype it is 1783.72. For MN genotype it is 3045.31, and for last it is 1299.71. So let's start with the chi-square test. Chi-square test is a hypothetical test which is used to know the relationship between the categorical variables, and here the variables which we are using is the categorical because the genotypes are present into the three categories. So to know the relationship between the observed number and the predicted number, we are going to do is the chi-square test. So before going into the calculation, we have to define the two statements for any hypothetical test, that is the null hypothesis and the alternate hypothesis. Here, null hypothesis is that observed genotype frequency is in Hardy-Weinberg proportion. The alternate hypothesis will be exact opposite, that the observed genotype frequency is not in Hardy-Weinberg proportion. So to calculate the chi-square, there is a simple formula, that is observed minus expected divided by expected and then summation. So we will put this to the formula, their observed number of individuals and the predicted number of the individuals, and then we will calculate the chi-square. So let's calculate the chi-square test by putting in this formula. For MM genotype, the observed number is 1787 minus the predicted number is 1783.72 divided by 1783.72, and this one will be square. Next, for MN genotype, it will be 3039 minus 3045.31 whole square divided by 3045.31. And for last, that is NN genotype, it is 1303 minus 1299.71 whole square divided by 1299.71. So when you will calculate this, we will get is 0.027. Now we got the calculated value of the chi-square, that is 0.027. So we will compare it with the value present into the chi-square table. These chi-square table are easily available online. So before seeing the value in the chi-square table, we have to define the degree of the freedom. So here there are the three observed number, and on these numbers we are putting two constraints. So the degree of freedom will be 1. So what are these two constraints? The first constraint is that the summation of the expected number should be equal to 6129, and the second constraint is that the estimation of allele frequency is from observed number. Then later these allele frequencies has been used to calculate the expected frequency. So these are the two constraints we are putting here. So the degree of the freedom that we got is 1. And when we will check the chi-square table at 0.05 significance level, at 1 degree of the freedom, the value is about 3.841. So here we can see that our calculated value is way smaller than critical value of chi-square. It means we will accept the null hypothesis, that is, the observed genotype frequencies are in Hardy-Weinberg proportion. And this is one of the most simple example to show how these Hardy-Weinberg principles work in real population. So that's all for this video. Thank you.